Hi, this is our second lesson in our prerequisite chapter, and today's topics are exponents and scientific notation, which kind of go hand in hand. What we want to do quickly is review some of the properties of exponents, and we'll begin with the negative exponent rule. What this says is that a number raised to a negative power, like a raised to the negative nth, is the same thing as talking about the reciprocal of the number, so 1 over a raised to that positive power. So a to the negative n becomes 1 over a to the n. Or if you think about it in real terms, that negative exponent, what it's telling you is that those n powers of the variable don't belong in the side of the fraction they're in. They belong in the other side. So if we had a to the negative n, then those powers of a go to the denominator of the fraction. If we started out with something like this, 1 over a to the negative n, then the same thing is true. The negative exponent tells us that we want the reciprocal of this, so this would be the same thing as a raised to the n powers. All that negative in the exponent does is tell you, look, I'm in the wrong side of a fraction, put me on the other part, right? The zero exponent rule is one that we will mostly all remember. It says that anything raised to the 0th power is 1, as long as the anything is not 0. 0 raised to the 0th power is not defined. The product rule talks about multiplying powers of like bases. So if I have a to the m multiplying a to the n, the rule says like bases, add the exponents if you're multiplying. So a to the m plus n power. The power rule, which sometimes people mix up with the product rule, says that if I have a power, like a to the m, raised to a power, I multiply the exponents. So this would be a to the mn. The quotient rule is kind of the reverse of this one. It says that if you have a to the m divided by a to the n, instead of adding, which you did when you multiplied, you subtract the exponents. So that, where you've got the same base in the top and bottom of a fraction, you subtract the exponents, so m minus n. The power of a product, that means, suppose we're starting out with something like this, ab raised to the m power. The m goes to both things inside. Okay? As long as they're hooked by multiplication, it's a to the m, b to the m. And the power of a quotient is similar to that. It's just if you had a in the top and b in the bottom of a fraction, they both get the power. So it would be a to the m over b to the m. And those are the exponent rules that we learned in our algebra classes. What we want to be able to do is simplify exponential expressions. To consider an exponential expression simplified when each variable appears only once. Each variable appears only once. And all exponents are positive. All right, those are the two rules we have to live by if we're going to simplify these exponential expressions. I'm going to ask you to start here. We have a product in here, that is, everything is multiply, and some of the terms have exponents, but this exponent, the 4th power, has to extend to all of them. So we're going to end up with 2 to the 4th power times x to the, and it's power to a power, so that's multiply, x to the 12th times y to the 24th. That's a 1 right there. The only thing you can do to make that look prettier is realize that 2 to the 4th is 16. So 16x to the 12th, y to the 24th is that expression simplified. Here we're multiplying exponential expressions, and we've got some like bases, so we're going to apply multiplying powers of like bases here. First we're going to start with the number parts. Negative 6 times 3 is negative 18. Then we have x squared times x. That means there are 3 powers of x altogether. This one had the first power, even though that wasn't written. And then our y's we have 5 here and 3 more here, so y to the 8th, and that expression is now in simplest form. In this one you can see we've got exponents top and bottom, and we have a negative exponent. So we're going to have to remember a few things here. Let's look at the number parts first. 100 divided by 20 is 5. Now the x's, we've got x's in both places. And this is the way I think about it. The rule would say that you subtract exponents since it's a quotient, so it would be x to the negative 4th. Here, y would go to the 2 minus negative 4, and 2 minus negative 4 is 6. This is still not simplified because we have a negative exponent there. So those 4 powers of x, they belong in the bottom of this fraction. 5y to the 6th on top, x to the 4th on the bottom. Very good. Our next one has an entire fraction raised to a negative power. Well, negative exponents are all about reciprocals. So the first thing to do in this one is flip everything upside down. Bring that y to the 4th to the top, 5x to the bottom. And once we've made the switch, now we're to the second power, right? The negative was just telling us to switch places. And now we're going to apply that 2 exponent here, and we're going to apply it there. So y to the 4th to the 2nd, that's y to the, you multiply here because you're raising a power to a power, y to the 8th over, and it will be 5 squared x squared. 5 squared x squared. That exponent goes to both parts of the product. 5 squared is 25, and we can write that to make our expression be in its most simplified form. Very good. We're going to move on to the scientific notation part of this lesson. Scientific notation is just a way to let us do math with really big numbers or really small numbers, and it uses the properties of exponents that we just looked at. A number is in scientific notation if it follows this format. A times 10 to the nth power. A is a number that must be between 1 and 10. That is, you can only have one decimal point or one place to the left of the decimal point. So A has to be between 1. It could be 1, so I'm going to put less than or equal. And A has to be less than 10. Between 1 and 10, it cannot equal 10 because you can only have one place to the left of the decimal. It's also true that n must be an integer because the power that you raise 10 to has to be an integer power. So it has to be -1, -5, 6, something that's a whole number, positive or negative. N is an integer. All right, some things that help me when I'm working with scientific notation is this. A number that has a positive exponent is a large number. That is, if I'm looking at 10 or at 2 to the 6th, 2 times 10 to the 6th, that means that I'm talking about a really big number. Positive exponent, large number. A number with a negative exponent is small in value. Okay? It has a small absolute value. Whether positive or negative, its absolute value will be small. If you make the absolute value of a number look smaller, so say I'm going from 12 to 1.2, I made that look smaller, that means the exponent increases. On the other hand, if you're making the absolute value of a number look bigger, you decrease the exponent. And I've got a couple of problems that I want us to look at here. We're going to put these two numbers in scientific notation. This is a big number. It's going to have a positive exponent. You're going to move the decimal point so that only one place is in front of the decimal point, 5.21 then. Right, we move it from here to here. And then we just got to count the number of places we moved, and it was 9. So 5.21 times 10 to the 9th. On this one, we're going to make a small number look bigger. That means we're going to have a negative exponent on this one. We move the decimal point so that there's one digit in front of it. So 6.893 times 10 to the negative. I know it's going to be negative 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7th power. All right, now we're going to put these numbers in decimal notation. That means we want to write them the way that these appeared. So we're going to, this is 10 to the negative 9th. Goodness, that means we have to have 9, well, let's, okay, learn to think. We got to move this decimal point 9 places to the left, 9 places to the left. One of them is already taken up by that number, so this is how I think about it. I got to go 9 places, but one of them's already gone, so I need 8 zeros. So point 1, 2, 3, 4, 5, 6, 7, 8, 2, 6. 1, 2, 3, 4, 5, 6, 7, 8. Yep, if I moved it to here, it would be 9. So I'm just double checking myself. And it's negative, so a negative sign belongs out there. Okay, it was negative because of this, not because of the exponent. The exponent makes it small. The negative makes it negative. This one, 3.017 times 10 to the 6th, we got to move the decimal point 6 places in that direction. So we're going 3, and here's 1, 2, 3, 4, 5, 6. There's that number in decimal form. All right, let's do a little math with scientific notation. The best way to do that math is to work with the numbers first and then worry about the exponents. Work with numbers first. And then work with the exponents. All right, got a couple of problems here that I'd like you to try that on. It says that we want to do the indicated math and put the result in scientific notation. So really what we need here is number times number, 7.1 times 5. See, this is all hooked with multiplication anyway. Then times 10 to the 5th times 10 to the negative 7. And I probably will not write that out again like that, but I just wanted us to be clear what we're doing. 7.1 times 5 is 35.5. These are powers of like bases. We add the exponents, so it's going to be 10 to the negative 2nd. However, we're going to make a big number look smaller because this is not in scientific notation yet. That number there can only be one decimal place in front of the decimal, one place in front of the decimal. So 3.55, and we made a big number look smaller. That means that we increase the exponent. So instead of 10 to the negative 2, we need 10 to the negative 2 plus 1. That puts it to the negative 1st power. 3.55 times 10 to the negative 1st. Over here, same thing. We need 1.2 divided by 3. Grab my calculator. 1.2 divided by 3 is 0.4, which I should have probably known without my calculator, times 10, and now we're subtracting exponents. We have a quotient here, so 10 to the 6th minus negative 3. 6 minus negative 3, that's 6 plus 3, so times 10 to the 9th. This is not in scientific notation though, because see, we don't have a number out here in the front. We need to have one place to the left of the decimal. So we got to move the decimal point one way right. It's going to be 4. We're making a small number look big. That means that we're going to decrease the exponent. And make a small number look bigger, we're decreasing the exponent, so 10 to the 8th there. Good. We've got one word problem today that has to do with scientific notation. Pell Grants. I applied for Pell Grants. They help you to get to college, folks. In 2006, the federal cost of this program was $13 billion, and there were 5.1 million grant recipients. And then it says how much to the nearest 100 was the average grant. I hope that you will not put this with all the zeros. Just think a billion is 9 zeros, so that would be 1.3 times 10. And since we made the 13 into a 1.3, we got to increase that 9 to a 10. So we're 1.3 times 10 to the 10th. We want that divided by the number of grant recipients there were, and that's 5.1 million. Well, 5.1 and a million is 10 to the 6th. All right, so the work says, or the rules say, do the work here, 1.3, get my calculator, 1.3 divided by 5.1, that's 0.25, about, and then it's do the arithmetic here. We've got like bases and a quotient, so we're going to subtract exponents 10 to the fourth. Now, this is not in scientific notation, and it would make sense probably to take this all the way out to the decimal because then it makes sense to people, right? We don't get right off the bat 10 to the 4th, or I'm taking 0.25 times 10 to the 4th. I'm going to move the decimal point 4 places. So I'm going to have, there's 1, 2, 3, 4 places, and the average grant was around $2,500. All right, that's our lesson on scientific notation and exponents. Get out there and try the U-Try as soon as possible, please, and we'll see you in class.